And share a screen. Okay. Great. All right. So hopefully you and except for you, unfortunately, the rest of you have at least one image that mostly came out so you can play around with it. And what we're going to do today is kind of do a recap, which we've just pretty much finished around questions and answers about your image requests. I'm going to do a little demonstration of using the image analysis tool, so that will be the next thing you do to play with your images. And we have some archived images in case you didn't get images right away and you have to request more. There are a list of images that have been taken in the past to play around with. And then we'll do kind of a walkthrough of the YouthAstroNet curriculum resources that are on the educator portal, and highlighting how those curriculum resources kind of reinforce how they're associated with the essential elements of a YouthAstroNet program, and how they reinforce the ideas of listening to student ideas and the sky belongs to everyone, and many ways to be a science person. So just to kind of put your cloudy images in context. So the microobservatory telescopes, they don't sit in a dome, unlike professional telescopes. Most astronomers' professional telescopes, where they want to protect the instrument from the weather and they only open it up if it's clear. We take images. The telescopes are really very hardy. They're purpose built to take images rain or shine, and they're reflecting telescopes. So there's a mirror, a 6-inch mirror at the back of the telescope, and the light comes in the front, the opening, the 6-inch opening. It bounces off that mirror, off a second mirror, and off to a detector, which is a digital detector like a phone. So you get a digital image from it, and that's what we're going to explore today. And you have the choice of these filters when you make your request. So when you made your request, you had a few settings. You chose the field of view, and that actually, I think a couple of you chose the Milky Way and you choose that through the Finder. And that's, if I go back to this, that has a wide angle field of view, so you get a lot more sky to see the Milky Way, and that's what you're choosing, that big fist-sized piece of the sky if you're choosing the wide view, and a pinky fingernail-sized piece of the sky if you're choosing the normal view. But then you had to select an exposure time, and each of these things you're selecting is actually controlling a physical mechanism in our telescope. And so the exposure time is controlling how long a shutter, those of you who know about, old-fashioned cameras that actually have shutters, the shutter opens, lets light in for a certain period of time, and then closes. And so the dimmer the object, the more light you have to let in, and the longer the exposure time. And so that's what you are setting when you choose these. And your Hercules 30-second exposure times, for some reason those failed, and we'll try and get you those again. So the third thing you choose is a filter, and it turns out that inside the telescope, right above here, right, this little pink thing, which is a round filter wheel on its side here, is right in front of the digital detector. And so when you choose that filter wheel turns around and either there's no filter and all the light gets through to the detector, or with the red filter, only the red light gets through to the detector. With the green light, only green light gets through. And we'll talk about, we may not get to it today, may have you view the video tutorial on how to use those 3 color filtered images to create a color image of the object you observed that represents the actual colors that that object was emitting in space. So once you made that request last night, the images in, this is the one in Arizona, the sun sets, they start looking at the queue of images that are requested and start moving on their own. They're automated telescopes. Those images get taken all night, and then the system looks for what images got taken at, we've just changed this to 9:15 in the morning. So those of you who have 8 a.m. classes where you want your images, you want to take them 2 days ahead because the system, because the Arizona telescope is 3 hours earlier than the East Coast, those telescopes are still taking images up till 9 a.m. Eastern time. So anyway, your images from the night before kind of get collected into your account at about 9:15 in the morning. Okay. And as I said, you might get images, and a couple of you did, that look a little bit like this. So with clouds in the images. Okay, so now what do you do with an image when you get it? What we're going to do is do some of that essential ingredient of a YouthAstroNet program, which is sense making from images. And so I'm going to go to the education portal here, the educator portal. Actually, no, I'm going to go to the activity portal and open up my robotic tools here. So I'm going to go use the images in JS9. Okay, so I'll click on that. And JS stands for JavaScript. This is a browser-based, it's kind of a Photoshop for astronomers. Okay, it's an image enhancement, but also an image analysis tool that works especially with images that come from telescopes. So there's a lot of key features that this has that are really optimized for paying attention to the data that's behind every image in that comes from a telescope. Oh, and the 4L stands for learners. So it's JavaScript 9 for learners. All right, so when you first open this page, there's nothing there. But you'll see if I roll over each menu item, there's a list of archived images that are always there. So if for some reason you didn't get images, but you want to help kids learn how to process, you can use the archived images. Your personal list from your account will be next to that. And you'll see I got some images from yesterday with the date, and I have some from earlier dates, all those. And then there's other menu items, and we'll go through some of these right now, and you'll view some of the tutorials to learn about other ones. Okay. What I want to start with is actually not an astronomical image. I'm going to start with an image of a skyscraper that's across town from where I'm sitting here in Cambridge. It's closer to where Adrian's sitting, possibly, but anyway, it's in Boston, and it's the Prudential Building. So we took a picture of the Prudential Building, which is 4 miles away, from using the micro observatory telescope that's on the roof where I am. And so here it is. I'm going to click on that, and there it is. We took a picture at night. So the Prudential sky, you can see it lights up. It has lights on it. So those are the brightest parts of the image. And I'm going to actually open up 3 of the JS9 tools and have us do some sense making together. So the 3 tool, I'm going to open up those first 3 tools in the tools menu. Pixel table, I'll open that up. And when you open tools up, you can move them on the screen where you want them to be convenient. So I'm going to move that over here. And I'm going to open up the magnifier. I'm going to put that here. Okay. And then I'm going to open up something called a panner, which helps us kind of locate where I am in the main window. All right. So I'm going to, so you'll see I've got a main working window where I'm looking at the results of any actions I take. I have some tools that are giving me information about the image. And I have this panel down below that's the adjust image panel. So I'm actually going to zoom in maybe twice on this image. Zoom in once, zoom in twice. So now I'm 4 times, right? And you see the zoom 4 is lit up. That's probably very tiny on your screen. Sorry about that. So what I want us to do is you can either take your microphone off or type in the chat. I want you to take note of as many things as possible that you notice as I move my cursor around the screen. What are some things you observe in all these different, in the main window and also in the tools? So it can be the simplest observation. As Adrienne says, she's always encouraging her students to say, what do you see? So it can be the simplest thing, but anything.
In the one tool over there, the bottom left one, it's kind of giving a large view of wherever your cursor is.
Yeah, good.
I noticed like on the table with all the numbers that they're changing every time. As you move it, the highlighted rows change.
Yeah, good, good. Crystal or Anne, any observations about what's going on anywhere?
Light. Use the right.
I'm sorry, Anne, we had a little trouble hearing you. Oh, she's freezing up. I see. All right. As opposed to being cold, I think. Yeah, is that right? Okay. Any other things people are noticing? Crystal?
Sorry. On the main screen, the pixel value and the location are changing as well.
Yes, yes. So right here. So those are changing.
What do you all notice about the pixel value changes? You're noticing them changing. How are they changing?
How would you relate the pixel value to what you see in either the magnifier or the main window?
If I'm seeing it correctly, the darker the color, the lower the number.
Okay.
Yeah.
Yeah.
Yeah. Exactly. Right. So the thing that comes from telescopes is not images. There's an image doesn't come to your computer account. The file is actually a whole bunch of numbers. It's a whole bunch of numbers associated with where they were on the detector. what do you think the down here, these two numbers might mean? Does anybody have a potential interpretation of that?
Okay, don't judge my lack of vocabulary here, but would it be like longitude, latitude, but for like the sky? Because it says
Okay.
physical location.
Yeah, it could be, and for some telescopes that encode that information, it would be. But this is actually a much simpler location than latitude and longitude on the sky, which is great vocabulary. That's perfect. Right. If I go way over here, have I got this right? Oh, I'm zoomed in, so I can't do that. All right, wait a minute. Let me zoom out. I'll go way over here and way down here. Whoops, sorry. And then I'll go way up here.
I can see those values changing, but I can't read them.
You can't read them. Okay, when I'm
Yeah.
down here, it has 1 and 3, 1,3, and you
Okay.
can see it in the blue too. If you look at the blue crisscross on the pixel values, you can see that the pixel value
Oh,
of the
okay,
pixel I'm on is 319, and
okay.
it's at the intersection of row number 3 and column number 1 on the detector. This is just each one of these little positions is the specific pixel location that was on the detector. And our detector has how many by how many pixels?
So that's what I was talking about in the stuff I was reading. I was talking about the 500, I think it was 500 by 650.
Look at the blue intersection.
Okay,
Yep. So in a single image, there are 500 times 650 pixels,
okay.
about 1 million pixels. And so this information tells you everything about them. All right, so let me zoom in to that twice again. Wow, wait, somehow I know what I did. Ugh. Okay, it's that stupid. There we go. All right, I just reset the image to where it was at the beginning here. So I'm where am I here? I wanna. All right. So now I'm going to use these tools here, and I want you to do some sense making around what these tools do. So notice this value, that high brightness value is 4095, and as I bring this down, tell me what you might have noticed. I'll go back up and down.
It looks like it seems to me that I'm seeing more detail in the building.
Yeah, okay. So especially in this place, of course, I'm seeing less detail over here near the P, right? I'm kind of blowing that out. Okay. And so these controls, let's take, what do I want to do here? I'm going to look at this little second light at the bottom here. And I'm at this pixel here at 198 and I don't know, where is it? 198 and 274. Its value is 435. I'm gonna go back to that same 198. Oops, lost it. Here it is, 198, and it's still 470, whatever I said there. Where, oh, geez, I really blew this. 435. It's still 435. The data is still there. It looks different, right?
And
Yeah.
while
Erica.
you're doing that, Mary, I want to point out that bar underneath the image.
Yeah.
And I think this always helped me kind of better understand what's happening here. As Mary changes that high brightness limit, it might be hard for if you've got a smaller screen.
Yeah. Can I make this bigger? Let me on my screen for you. Let's try. Might, yeah. So that might help a little.
So you've got a bar there with shades of gray, and then you see there's some numbers underneath it. And as Mary changes either that high brightness
So-
limit there, it's kind of our original display. You can see the numbers go all the way up. I think the last list of numbers,
It's
3,700.
3,700.
Clearly some space to the right of it. But then when she moves that high brightness limit,
Now, pixel values of only 700 get represented as white. Whereas before, the high brightness limit, you had to be as high as 3,000 to be represented as white. And there's far fewer pixels that are as bright as 3,000. So what you're doing here is determining, I want to see lower and lower, dimmer and dimmer pixel values get a higher white value, gray value, so that I can see them. Now that might blow out the brightest images, because now all these pixel values that are brighter, they all look the same, even though these are all different values. Anything higher than 655 is painted, and here's that 655. Anything higher is painted white.
and I think a really important thing to think about here is with your students to remind them that that's not wrong, right? Or right. Right now, Mary's trying to help us see those dim windows and structure in the building over there on the left. In order to see that, you might not be able to see the name of the Prudential as well. If we want to see that, then maybe we don't see this part as well, right? Because there's just so much dynamic range in an image, and you're just looking for specific details that you want to investigate more deeply. And that's the decisions you're making as you do this processing.
So the same thing is true for scientists looking at science images. The way you decide to adjust the image, it might be for aesthetics, but it might be because you want to see details in a particular part, one part of the structure of that image. If I zoom out here, I can see in my panner here, I can see, I now start to see some of these dimmer windows down here. I'm getting some detail here. And if I bring this down even farther, okay, now I can't see any detail in the brightest parts, but look, I'm seeing the kind of exterior structure of the building. Maybe that's what I want to examine. So again, how you adjust the sliders and the adjustment controls all has to do with where are the things you want to look at, measure, what are the questions you want to ask of this image. And now I'm going to give you a trick for enhancing an image that has a lot of dynamic range like this one, where there's really bright parts and then there's really, really dim parts. Because a lot of objects in the sky are like that. You have really bright stars, and then there's this dim stuff that's in the background. And so this is a trick that is also in the video tutorials. So if you don't catch it right now, you'll catch it then. And the trick is this. Right now, you'll notice that between every number is the same amount. So between 241 and 278 is 37. And then you add 37 to that and you get 315. And you add 37 to that and you get 352. And you add 37 to that and you get 389. This is called linear scaling. A different shade of gray gets added every X pixel values, right? So step one in bringing out dim stuff is to, rather than do linear scaling, do something called log scaling. And I know one of you is a math educator, you indicated so in your introduction. So log scaling boosts the dimmest values more and the brightest values less. And in fact, I'm gonna bring this back up. So log scaling. So now, and so that's step one to boost a dim image, is use log scaling. And step two is find the lowest pixel value in the image. And can anybody tell me what they think that might be? I think it's maybe out here in the dark sky somewhere. What would you say? It looks like 329 is in there or something like that, right? In the blue, I see a 329, a 330. And you set this low brightness limit. So anything 329 or dimmer is going to be dark. So I'm going to just type in 329. I'm going to hit enter. Very dramatic. So now we get both the bright prudential and the dim. I'm starting to see some structure up here on the top of the building. I had no idea was there. It looked like these might be stars hanging out in the sky, but in fact, now you can start to see there's all these antennas on top of this building, and there's these, you know, dishes, all kinds of stuff. So again, images from telescopes are really just numbers. And the numbers relate to how much light, how many photons of light were focused on that spot on the detector. Out of 650 by 500 spots, how much light was focused there? And so that's what you're getting. And let me zoom out a little bit here. Okay, now I'm starting to really see all the details of this skyscraper that I didn't see before. A couple of the other things when you get your images, your astronomical images, or you can try with this prudential as well. It's in your archive, so you can try bringing out these images. Then right now, every number is represented by a shade of gray or white or black. But maybe I want to try this cool.
Ooh.
Ooh, yeah, now there's a shade of blue or black or white. Or maybe I want to try this, it has this weird name, viridis. Ooh. This is a little weird. It's kind of yellow and blue, but I will note that this is actually a popular color palette among astronomers who are colorblind. Because it turns out that all these distinctions in brightness are much more apparent to someone who's colorblind in this particular color palette. Color map is what we call them, all these things. Okay, so now I want to save this image as a PNG. The images that come from the telescope are what are called FITS images. That's a special astronomical format. And so when you save a FITS, all it saves is the original data. So it won't save all the processing you did. So you really, if you like what you did, you want to save it as a PNG or a JPEG image. And so I have that now, and I can, I open that. There's my image. Okay. Okay. Where are we here? We're getting to I wonder if I should demonstrate how to post this in the showcase, since that's your homework. Maybe I should, because you'll all want to process one of your images or one of the images in the archive, and then post it in the educator showcase. So that's where am I here? I'm going back home here. So my assignment is to post it. I already posted one image, which I've used an advanced technique, so pay no attention to that at the moment. You'll be learning that. You don't need to know it now. So I'm going to add an entry. And if I can either find that image I just had and drag it here, or I can add it, upload. Here it is, my Prue here. Okay, and I'll upload this file. And there it is in the image showcase. I'm going to add prudential in green, yellow, blue. And I guess it's in the solar system. How much have we lost? Okay, we're back recording, having just uploaded the image we created into the image educator image showcase, and apologize for whatever part of the recording we lost. We'll re-record.
As we're looking at this, a couple things I want to point out just for your use. There's a nearly identical showcase for your students in the activity portal. So this is a great place to have them share images that they're proud of, or if you have an assignment, you can have them post them there. In the block called Image Showcase.
Image Showcase, yes.
So this is nearly identical to theirs. Opportunities for them to put some text below it. The other really nice thing,
Okay.
Get back to ours, Mary.
Yep.
I'm gonna have to
Going back to the educator portal.
yeah, because
Okay.
it looks like something I need to hit a setting there that seems to be off temporarily, but I will fix it.
Okay.
If you look at the image, you can also comment on each other's posts.
So.
Oh, maybe you have to actually be on individual. That's what it was. It's not that it's off, it's just in the single view. Silly me.
So if I go to the next one.
You can add a nice little comment there. If as an educator, you want to comment on your students' images, or you want to make an assignment to have them go in and comment on each other's. This is a great place for kind of that interactivity that we talked about, how important it is for students to post and ask questions on the portal.
So
Mary's very proud of her image.
I'm very proud of my image. All right. Excellent. So any questions about how the JS9 works? The only thing I can do is tell you, play around with it. You cannot hurt anything. You cannot ruin anything. There's no wrong answers. Everything you do is useful to learn the data that's behind an image. Okay. All right. So in our remaining 20 minutes, what we wanted to do is actually start to give you a walk through the actual curriculum resources. So you can start to think about, okay, I know what the basic tools are. You can get these images from a telescope and you can enhance them. There's all kinds of other things you can do with them too around making measurements. And we'll do some of that in the next webinar and through the tutorials. But then how do you structure that into some implementation of a experience for youth? And so down here under curriculum, in the curriculum section of your educator portal, you'll see we have the curriculum overview that kind of gives you just the, there's essentially the YouthAstroNet collection of resources has 9 units. And actually, I think if I go to my slide set here, these are the 9 units. Introduction to YouthAstroNet and the telescopes. We kind of did a little bit of that last week. I'll show you more what's in there. The second unit is analyzing and processing in astronomical images, investigating telescopes, investigating technology, sensors, pixels, and digital images. So taking a deeper dive into that idea that there's math behind the images, exploring light and color, and then investigating the moon. Often in middle school, students are learning about phases of the moons, exploring distance, size, and scale, which you can do with microobservatory images, investigating the universe, and then the capstone unit. There's a few materials to help students develop capstone projects. And notice that 1, 2, and 9 are in red. And that's because those are the essential things. If you only had time to have a week's worth of YouthAstroNet, so you're going to do an hour in a day plus some homework assignments for kids. Typically, we think you really can't do YouthAstroNet in less than 8 hours of experience for kids. But let's say you had, you would want to make sure they take some telescope images and know a bit about them. You would want to give them and do some processing and then create something out of those images. But let's go look at the curriculum so you can see what more there is. So back to the portal here, and I'll go back to the curriculum section. So it's in this folder called curriculum, and there's the 9 units. And if I open up the first unit, we have a bunch of things to help get students started. And you remember that we, in our first webinar session, we started sharing our kind of astronomical personal connections. And so there are a couple of activities in this folder that are all about helping students make personal connections to the universe. And one is this everyday astronomy guide. And this is an activity I know that Adrienne uses a lot when she facilitates the activity, facilitates YouthAstroNet. And this is all about having students think about what are all the items in their everyday lives that have astronomical connections. And so, I don't know, Adrienne, maybe you could say what kids come up with when you ask them that.
When we do this activity, the kids have a lot of fun. We put them in groups, and what they talk about is, especially like movies. When they talk about movies, they're talking about Star Wars, and they're talking about all those galaxy movies and stuff. So they really get into relating with the universe with the Star Wars and
Science fiction
even
kinds of
with
things.
the Black Panther and the
Guardians of the
Marvel
Galaxy, I
and the
think is the
Galaxy,
movie you're
right? So they
thinking of.
really get into having fun with that. But I think the fun thing is trying to say, okay, when we think about candy, and that becomes they're trying to see who's got what for candy because they don't realize they've never put these astronomical names to candy bars. So they have fun with it because when you get them all back together again and they see what each group comes up with, they're like, wow. And then some of them, they don't even cannot understand like household products, that they're not relating to what astronomical words or something that comes, to their mind when it's household products. So I always tell them, go ask your parents and see what they come up with. So because they can't think of anything that has an astronomical name for something within a household. So the kids get into it, but then when they take it back to their parents, the parents will have fun
All
with
kinds
it.
of
So
other connections.
yeah, have other connections.
Particularly if anybody speaks multiple languages, right? You can start bringing in even more
yes.
products. That's a great way. If kids at home, if their families speak Spanish or any number of languages, those are used in a lot of products
Right.
as
In
well.
fact, I'm going to launch a little game right now. My everyday astronomy match game. If you want to try it out, even the days of the week have astronomy connections. And Spanish speakers are, this is helpful for, is anyone answering this? I don't see anyone answering it. Come on, you can make some choices here. So from the pull down list next to each day, choose the astronomical object that you think might be connected. And I'll just note that in French, Tuesday is right, Mardi Gras.
I can
And
sing you the Spanish song
Wednesday,
for the days of the week.
yeah, what's the Spanish days?
Lunes, martes, miércoles, lunes, martes, lunes. Yeah. Jueves, viernes, sábado, domingo. There we go. I have to do it in sing song in my
There we
brain.
go. Yes. So
Jueves, viernes.
right. Which day is
Friday.
Friday, right? There's definitely begins with a V. I can't remember what. Anyway, all right. I'll end the poll. I see that no. Oh, wait, somebody. There we go. Let's see. Let's share the results. All right. Yes. So Sunday is the sun. Monday is the moon. Tuesday, Mardi is Mars. Wednesday, mercredi in French, so Mercury. In Thursday, I know the French is jeudi, jueves, right?
Jueves with a J.
With a J for Jupiter. Friday, vendredi in French. So
Viernes and
viernes, yeah, in Spanish. And of course, Saturday in English, Saturn is, yeah. So anyway, everyday astronomy is there's more astronomical connections in your life than you realize. And that's one of the activities in the introductory unit, along with I think in the slides on the other day, I talked about the modeling the universe activity, and I showed an image of kids' models of the universe to help them articulate their own ideas. So that idea of listening to student ideas about what's in the universe.
And as you say that, Mary, I want to just point out that in many of our activities, and at some point all of them, we've written out some of the different ways that these activities do, or that you can support embracing those core principles that we introduced you to on Tuesday. So these are all written out right here to really like help frame your mind as you're thinking about running these activities with your students, how you can listen to their ideas more intently, how you can support them thinking about many ways of being a science person. So those are all written out in a number of the activities for you.
So the modeling the universe highlights that a couple of the STEM profiles on the youth portal of astronomers who use models. So, okay. And then unit 2, which we're just embarking upon today as learners ourselves, is an introduction to image processing. And so there is there's a guide for educators, and then for students, kind of a guide that has some sense-making questions. So open up an image. Where do you find the highest pixel value? Describe what it looks like. And then it asks you to make a change in the slider, and then look for the highest pixel value again. Has it changed? No, of course not, because the data is still there, right? So there's some sense-making scaffolding questions for students to make sense of images in this guide.
If you'll go back, so this one is really kind of technical sense making, right? What's happening in the technical image? If you open it,
Yep.
it again, unit 2.
Unit 2, sorry, thank you.
There's also a sense making activity guide. And this is really more kind of thought-provoking sense making, thinking about the object themselves. What do they see? And some of these questions are, the See, Think, Wonder, Project Zero, thinking strategy.
Protocol. Yeah.
There's the word I wanted, protocol, based on some of that. But an opportunity to really have your students look at the object more deeply and what do they see. Another way to do this is in the astropoetry activity. That's currently in unit 1, but I think I'm gonna move it.
I think we might put it in unit 2, yeah.
Another way, to even more creatively do that is to encourage your students to do an astropoetry activity where they look deeply, they come up with as many words to describe the object as possible, and then they turn them into poems.
So this is a great activity where kids just brainstorm descriptive words that describe what they see in the image. They generate those words on index cards or Post-its or whatever, and then rearrange all the words into a poem. It's a great looking closely activity, because you have to generate adjectives and verbs and nouns and adverbs, right? Action verbs that describe what's going on in the image. And so it really both helps kids attend to the image, but it comes out with kind of an aesthetic expression, and the poems that kids come up with are really great.
And also with this is letting them feel comfortable. There's no right or wrong answer of what they see, because we may see something totally, they may see something orange in there and we're looking for it, but you just want to reassure them that, it's, this is your vision, this is what you see, and how do we tell a story behind this image, even though our perceptions may be totally different, because you want them to feel really proud of and feel great about what they see within that image.
Great. All right, so 1, 2, and then you could have kids take images of the just the way some of you did, the, the 3 categories of astronomical objects, solar system objects, stars and nebula, galaxies, and then create a capstone project with astropoems about what they observe in their images. That's a reasonable short implementation of YouthAstroNet, kind of a couple workshops or a 1-week exploration. And we have a particular capstone instructions around creating an astrophotography exhibit. A lot of our educators have done this as either a family showcase or something for the school where kids create an exhibit of their work, and that's their capstone to show a larger audience. And so there's some suggestions for how to guide kids to create a well-rehearsed oral presentation and a bunch of elements to their exhibit. And then there is a checklist for students for their astrophotography exhibit. What are the things you need to pull together? And you could obviously create your own for this. What are the things, if you're teaching about the moon and moon phases, you want an exhibit about the moon, you want to make sure they have at least 2 phases in their exhibit. You want a caption about those 2 phases and what's happening. Again, you can help scaffold the particular learning goals that you have for students, along with the general YouthAstroNet learning goals of engagement, skills in image processing, some astronomy content knowledge, and science identity, a feeling of belongingness, and interest in careers. Anything else, Erica, you think we should show at this point? I don't want to.
Just 2 or 3 activities that I don't know that we need to show, but I want to make sure people know are in there.
Yep.
Investigating telescopes. There's the kinesthetic telescope activity.
Yes.
Which is a really great way for students to get a physical sense of what's happening when a telescope captures an image.
Yeah, and I like this particularly. We've kids who have never done this activity and have never used microobservatory, when asked how a telescope works, will never use the word light. They'll say a telescope magnifies or it sees things. But after doing the kinesthetic activity and using microobservatory, they have a much better sense that a telescope collects light, because in this activity, kids are photons traveling from the object in space to the telescope detector. Okay, Erica, next one you wanted me to.
And then in exploring light and color, there's kind of 2 different great versions of helping students think about color filters, which we did not dive into today, but you might have noticed, and we requested some our red, green, and blue images. There's Mary's got some of her color filters there.
See my construction paper in the back.
And so
We'll
helping
take a closer look next week.
so there's 2 different types of activities in there for helping students explore those color filters. And what does that mean? One of the big questions is, when you see a NASA image, right? Some of these new James Webb images, is that really what it looks like, right? And there's a lot to dissect in that. So what is the telescope doing? What are the color filters doing? And this is one great way to think about those 3 color images, or red, green, and blue.
So you might especially want to look at the tutorials about that and some of the material about that. And then I like in the investigating the universe, this is actually a great one to use with Erica's sense making from images worksheet that we just saw about what do you see, and that is portrait of the universe. And so in this activity, kids take images of lots of different things and have some sense-making questions around, why don't you see stars in the background of your moon image? That's a tricky one. It has to do with exposure time. So anyway, all of these, again, we're really trying to focus on sense making and students being able to articulate their ideas about what's going on. Any questions up to this point? We're kind of throwing a lot at you. There's a lot of material, right? There's kind of a lot to learn because you yourself are being learners, trying to think, okay, what are these telescopes doing? What am I doing with this image processing? What's happening? And then you're also trying to think, all right, how will I use this with students? So I know that takes a while to negotiate those two hats that you have on as a learner yourself and then as a facilitator for your students. So we're definitely here to help you with that. And there are lots of educators who've done this before who have, we actually have a group of peer educators. One of them popped on, Stephen, and of course, Adrian's here as well. And in the curriculum area of the portal, you will see a YouthAstroNet educator developed materials. And for example, this moon study that Raquel has done is kind of good if you're helping kids go through the moon, and I'll just open it for you because she gives lots of pictures. She has a rubric. She kind of says, okay, this is what I want kids to do with their moon. They're going to make a capstone exhibit of moon images. I want to make sure they have 2 or more lunar phases. She gives them a rubric. Here's some pictures of them doing it and some samples of student work. So you can kind of see, what does the capstone look like? So she has them labeled, their images.
Yeah, so instead of just investigating the phases, they also investigated the craters and Maria on the moon, which is
Right. And here they're using the region tool, which I didn't demonstrate, but you can see these students have created some boxes and circles to highlight regions of their image. Okay. Giving a little wait time here. I know it's a lot to absorb, but are there any kind of burning questions at the moment that you just need time to try it all out and explore more? Yes, definitely. Okay. Well, so our next steps, keep exploring the portal and all those resources. The kind of assignment for you is to request more images from the telescopes and process at least 2 of them. So you yourself get a feel. You don't have to become expert, but try processing at least 2 images. And if you can, view the RGB tutorial, creating an RGB image. And in that, you open up 3 images at once in JS9, red filtered, green filtered, blue filtered, and combine them. And then post them on the showcase.
And in that, I'm going to point out just an opportunity to explore both your educator portal, but also the student portal. To be that tutorial exists in both
Yes.
portals, so that you always know where it is.
Here it is.
There's tutorials and other videos for students, and it's built into some of the places, just so that you can get a sense of what your students are going to have access to. Sometimes we fall into exploring our resources, making sure you get a chance to see what they're going to have. So when they go, where's that tutorial? you know how to point them towards their version as well as yours.
Right. Right. So each of these blocks in the student portal has resources for them to learn kind of on their own or with your facilitation. Okay. Well, thank you guys for spending some time with us again. We're really excited to kind of support you in integrating YouthAstroNet into your setting. So, you know, I know there's a lot to pull together, but we're here to support you, and there's others as well. And we also have the opportunity to potentially interact with some astronomers who both you can ask questions of and your students can. All right, we'll see you on Tuesday. Have a great weekend. And